Good afternoon all. Myself Monika Devi, working as a lecturer, Faculty of Nursing, Rama University. Today we will discuss regarding ECG, that is electrocardiography. For the basic concepts of the electrocardiography, we will discuss today. So electrocardiography means electrical activity of the heart is graphically presented. That means the electrical activity in the heart is shown in a graphical method, that is known as ECG. So already we know that ECG mostly will known as 12 lead ECGs. So ECG has 12 leads. What are the 12 leads? We will see. 3 leads we will known as standard limb leads. And 3 augmented lead. And 6 chest lead or precordial lead. So what are the 3 standard limb lead means? We are known as lead 1, lead 2, lead 3. And 3 augmented leads are AVL, AVR and AVF. And 6 chest leads are V1, V2, V3, V4, V5 and V6. These are the 12 leads. So now we will see the placement of the chest leads. So these 6 leads are chest leads. So these 6 chest leads, where are the placement we will see. This is clavicle and this is the ribs. This is the rib cage and this is clavicle. So what are the 6 chest leads? Where is the placement we will see. So first B1 we will keep under the 4th intercostal space. So B1 will keep at the 1, 2, 3, 4. 4th intercostal space of the right side of the sternum. So right side of the sternum, B1 is the placement. So move to the left side. That is 4th intercostal space of the sternum on the left side. This is the placement of B2. Next B4. So B4 will keep on the 5th intercostal space of the mid-clavicular line. This is the clavicle and this line we will known as mid-clavicular line of the 5th intercostal space. So B3 where we have to keep means in between the B2 and B4. And B5. B5 will keep on the just move to the horizontal line, that is 5th intercostal space of the anterior axillary line. And B6 will keep on the mid axillary line. B4, B5, B6 will be in a same horizontal line, that is 5th intercostal space. Next we will see the electrical activity of the heart. How electrical activity of the heart is related with the vector producing. That vector producing we will known as cardiac vector, and this cardiac vector will change into how it's change into the ECG patterns we will see. Electrical events of the heart in a cardiac cycle. These electrical activities of the heart, how it is related with the vectors. cardiac cycle is what vector is producing. That vector producing is called cardiac vector, and that cardiac vector is how converted into the ECG patterns we will see in details. So this is a right atrium, right ventricle, left ventricle. So electrical activity will start from the SA nodes. Here SA nodes will be present. In the normal heart, electrical activity will start from the SA nodes. SA node generates the depolarization. This depolarization moves to the downward and leftward positions. This SA node, electrical activity will start from the SA node, and this electrical activities will start from the SA node and will move to the downward and the leftward vectors. This is a small vector and moving downward and leftward and moderate velocity, with the moderate velocity, and this degeneration of the atria we will known as atrial depolarization. Atrial depolarization is the first electrical event of the heart. So SA nodes generate the depolarization, and that depolarization we will known as atrial depolarization. In atrial depolarization will produce small vector moving downward and leftward directions with a moderate velocity. After polarization of the atria, after both right side and left side of the atrium depolarize, all the atria will be depolarized, and this depolarization will move to the downward. So depolarization, after completion of the both atria, right side and left side depolarization, the depolarization will move to downward. But this depolarization hits on the fibrous annulus or fibrous tissue. In the fibrous annulus, it is not a good conductor. So the depolarization can't able to pass to the ventricle. So all the depolarization can able to pass only a single point, that is AV nodes. Depolarization from the atria cannot able to pass to the ventricle because this fibrous annulus is not a good conductor. Because of that, only a single point can able to pass the depolarization from the atria to, that is AV nodes. AV node is the only one single point that can able to pass for the depolarization. And here in the AV node, it is stimulation of the AV nodes. Stimulation of the AV nodes time heart is silent because of due to low conduction. It is a slow conduction and the needles cannot able to fluctuate, and it forms a isoelectric line. These isoelectric lines will form a P segment. Okay. After passing from the AV nodes, atrial will be repolarized. This atrial repolarization is very weakest, so it can't able to visible in the atrial repolarization. So after the AV nodes passing, the depolarization will start in the ventricles. So first electrical event is SA node, and second electrical event is AV node. After the AV nodes, so ventricular depolarization will be start. So this is the septal area of the ventricle. This area is the septal area of the ventricle, and this is the apex of the ventricle, and this is the basal of the ventricle, and this is the major part of the ventricle. So in the ventricular depolarization, it will take place 3 stages. So first is septal depolarization. In the ventricular septal depolarization, it will be moving upward in a rightward direction, outward with the rightward direction. It is known as ventricular septal depolarization. After completion of the septal depolarization, it will go to the major ventricular direction. So in the major ventricular depolarization, what it will be happen here? It will be a downward and leftward direction. This is the major ventricular depolarization, and this is basal ventricular depolarization. Now we will see the basal ventricular depolarization. So basal depolarization will spread here all over of the, it will be straight. So it will be goes to the all direction. Net velocity of the, it will goes moving in a upward and rightward directions. So in the ventricular depolarization, it will takes place 3 stages. So first stage is septal ventricular depolarization. In the septal ventricular depolarization, it is a small velocity, but it is fast velocity. Small and fast velocity, it will gives in a upward and a rightward direction, with the upward and rightward direction, and it is a fast velocity and it is a negative deflection, and it will form a Q waves. And after this septal ventricular depolarization, major ventricular depolarization will be start. So major ventricular depolarization, all area of the ventricular will spread for the velocities. So this velocity will moving to all part of the ventricle, and it will be goes in a net velocity, that is downward and leftward directions. So after the major ventricular depolarization, it will goes to the basal ventricular depolarization. In the basal ventricular depolarization, all the basal part of the ventricle will be depolarization. It will goes upward and a rightward direction, with the upward rightward direction. This after the occurrence of the ventricular depolarization. So here same like in the AV nodes, there is also no current or no deflection takes place. Likewise here in the ventricles also, after the ventricle is completely depolarized, both the right side and left part of the ventricular repolarization will be start. Before completion of the depolarization, ventricular repolarization will be start. Then in between of the ventricular depolarization and ventricular repolarization, there will be a gap. In that gap, there will be no fluctuation, no deflection of the needles. In that time, will produce a ST segment. This is the fourth electrical event. And after the ST segment producing, it will be produce a ventricular repolarizations. In the repolarization phase, all the ventricles will be repolarized. That is the last electrical event. So now we will see what is the relation with the electrical activities is converted into the ECG patterns. Once again I will repeat here. So electrical activity of the heart, it is start from the SA node. So SA nodes will be generates depolarization, and that depolarization we will known as atrial depolarizations. All the atria will be depolarized, and the depolarizers will pass to the downward. But because of this fibrous annulus, it is not a good conductor. Because of this depolarization cannot able to pass to the downward. Only a single point can able to pass from the atria to the downward, that is AV node. Here AV node is a very slow conductor. Because of that, it can able to fluctuate the needle. So because of that, it will form an isoelectric line. This isoelectric lines will be known as PR segment. We will see in the ECG. So after this AV nodal conductions, depolarization will start in the ventricle. The ventricle will goes into 3 stages. First stages is the septal ventricular depolarization. In the septal ventricular depolarization will take place moving with the upward and the rightward direction. It is a very fast, and negative deflections will take place and will form a Q waves. And major ventricular depolarization. In a major ventricular depolarizations, all the vectors will be moved in a leftward and a upward and a rightward, that it will be spread all area of the ventricles, and it will form a downward and a leftward directions. And after that, at the last part, basal ventricular depolarization. In the basal ventricular depolarization, the basal part of the ventricle will be start depolarized. It will be moves in a upward and a rightward direction. This is the relationship between the electrical activity and the vectors. So now we will see in the how it is related with the ECG patterns. So electrical activity will start from here as a node. So as a node generate depolarization, and the atria, all the atria will be depolarized. This is known as atrial depolarization. Is the first electrical activity, and it will produce a waveform, that is P wave. First electrical event is atrial depolarization. From the SA node will generate depolarization, and it will form an atrial depolarization, and it produce P wave. This P wave is known as atrial depolarization. After the atrial depolarization, both right side and left side of depolarization, the depolarization will try to go downward. But due to this fibrous annulus, it is a weak conductor, it can able to pass the depolarization to the ventricle. So it can pass only a single point, that is AV node. In the AV node, it can pass only a single point of the depolarization, that is AV node. Here in the AV node also, it is a very slow conduction. Because of that, electricals of the heart is silent here, and this electrical heart is silent because of due to that isoelectric line will be produced. After the P wave, it will produce an isoelectric line. This is called AV node. Because of the conduction of the AV node, it will produce an isoelectric line. This is known as PR segment. And after the conductions of the AV conductions, depolarization will start in the ventricle. So depolarization of the ventricle will goes under the three process. The three process will start from the in the septal area of the ventricle. This is the septal area of the ventricle. In the septal area of the ventricle, what it will be happen? Depolarizations will slow velocity, and it is a very fast. It will goes downward and leftward direction. It is very fast velocity. Because of that, and it is a negative deflection, and will form a Q waves. This is called septal ventricular depolarization with a negative deflection. After completion of the septal depolarization, it will be goes the second stage, that is major ventricular depolarization. This major part of the ventricle will be depolarized. In this, all the parts of the ventricle will be depolarized. All the part of the ventricle will be depolarized. For the net velocity, it will come as a downward and a leftward directions, and will form a R wave. It will be fastly reflect. Okay. So major ventricular depolarization will form the R wave. So next third stage is basal ventricular depolarization. In the basal ventricular depolarization, here also it will be moves upward and a rightward directions, and it will form a S wave. See, so ventricle has three processes. One is septal ventricular depolarization. Septal ventricular depolarization produces the Q waves, and it is a negative deflection. After that, it fastly moves to the upward. That is nothing but in the major ventricular depolarization form a R wave. And after the major ventricular depolarization, the third stage is basal ventricular depolarization. In the basal ventricular depolarization, it forms the S wave. This is also we will call as QRS complex or QRS intervals. After the ventricular depolarization, before completion of the ventricular depolarization, repolarization also will be started immediately. Ventricular depolarization. In middle of this ventricular depolarization, completion of the ventricular depolarization and starting of the ventricular repolarization, here electrical current it won't be passed. So in that time will produce an isoelectric line we will known as ST segment. And after that ventricular repolarizations will take place. Ventricular repolarization will take in a downward and a leftward with a small velocity, with a gradual velocity, and will produce a T wave. So this is the relation between the electrical activity and the ECG pattern. So P wave is nothing but it is an atrial depolarizations. So P wave means atrial depolarization. In the atrial depolarization, from the SA node, electrical activity will be passed and this atria will be depolarized. For whole part of the atrial depolarization, we will known as atrial depolarization and form a P waves. It moves in a downward and leftward directions. After completion of the atrial depolarizations, the depolarization will try to move downward, but this fibrous annulus is not a good conductor. Because of that, it can able to pass the depolarization to the ventricle. Only a single point can able to pass the depolarization, that is AV node. In the AV node, there is very slow conduction. Because of the slow conduction, heart will be electrically silent. Because of this, it will form an isoelectric line. This is the second event due to AV node stimulations. And after this AV node stimulation, it will be start for ventricular depolarization. This QRS complex together we will known as ventricular depolarization. In the ventricular depolarization, it is in the 3 stages. So first stage is septal ventricular depolarization. In the septal ventricular depolarization, it will be moves downward and leftward, and it is a slow and fast velocity and give a negative deflection and will form a Q waves. After forming of the Q waves, it will goes to major ventricular depolarization. In the major ventricular depolarization, all the ventricles will spread with a velocity with the downward, moving downward and leftward directions and produce a major ventricular depolarization and will form a R waves. After forming the R waves, in the vessel area of the ventricles will be depolarized. In the vessel part of the depolarizes will goes to move upward and rightward direction and will form a S wave. This whole QRS complex we will known as ventricular depolarization. And after completion of the ventricular depolarization, before completion of the depolarization, ventricular repolarization will be start. Before starting the ventricular repolarization and before completion of the depolarization ventricular, current will not pass. That will form a ST segment, and we will known as this is an isoelectric line. And after the ventricular repolarization will form a T waves. This is known as ventricular repolarization. It will goes move upward and the rightward direction with a moderate velocity. So in the waves, P waves, QRS complex, T waves. So P wave is a atrial depolarization. When the atria is depolarized, will produce a waveform that is P wave. And when the ventricle is depolarized, that time wave will be produced, we will known as QRS complex. In the ventricular depolarization, it will be undergoes 3 process. So in the 3 process, first Q we will known as septal ventricular depolarization, and R wave we will known as major ventricular depolarization, and S wave we will known as vessel ventricular depolarizations. So after completion of the ventricular depolarization, before starting the depolarization, the current it won't be passed. So it will form an isoelectric line and it will be produce the next waveform, that is atrial next is ventricular repolarizations. Next we will see the segments. What are the segments? The segments are the isoelectrical line that is produced in a straight line. And when the heart electrical activity is keeping silent, when the needle is not reflecting, that time a straight line will be produced. That straight lines we will known as isoelectric line. We will call as that part we will call as segments. How many segments in a cardiac cycles of the ECG pattern we will see. So after the P wave produced, from the P waves to the R before completion of the QRS complex. This we will known as PR segment. And after the QRS complex, that is ventricular depolarization, and before the ventricular repolarization, it will form an isoelectric line. This we will known as RT segment. So next we will see the interval. Interval means some cardiac waves, some waves and or some electrical events of the waveform with in the segments. Some wave or some segments or some waveforms we will known as intervals. So first we will see the intervals starting from the P waves and before the QRS complex. This we will known as PR intervals. Starting of the P waves, that means P wave plus PR segments we will known as PR intervals. In PR intervals, P wave and PR segments, this we will known as PR intervals. After the PR intervals, QRS complex will be start. QRS complex is nothing but it is a ventricular depolarization. From the ventricular depolarization, whole ventricular depolarization and the repolarization of the ventricle, we will whole events of the ventricle we will known as PT intervals. In the PT intervals, QRS complex plus RT segment plus T waves. This we will known as PT intervals. So easily PT interval means whole events of the ventricle we will known as PT intervals. Next we will see the timing and duration of ECG waves, segments and intervals. In the different waveforms, how much duration is takes place. In different segments, how much duration and how much timings is takes place we will see. So ECG is recorded in a calibrated paper. So calibration of ECG paper helps to determine the duration of the cardiac events or cardiac or electrical activities can be find out the durations, how much duration is taking place in the particular events. So this is a galvanometer and it will be connected with the positive electrode and negative electrodes to the body, and this is an ECG message. Okay, in the ECG message paper will be recorded. Okay. This is an ECG paper. During a cardiac cycles, during a minute, in a 1 minute, in a galvanometer, that is nothing but in machine, speed of the paper, speed of the rolling paper passes the 300 big box. Passes the 300 big boxes in a minute. Okay, in a minute, like this, the big boxes passes 300 of events in a minute. That is, this is one big box. Okay, like this is a big box. In a big box, 300 big boxes passes in a minute. of the speed. Duration of the speed is in a 1 minute it passes the 300 big boxes. So in a 1 big boxes there is a small boxes also. We will see the small boxes also. So we will take, this is a one big box. Okay, in a one big box it's presence of small 5 box. Okay. Duration of the speed under the pointer, under the needles, under the pointer, the speed of duration of the rolling paper is 300 big box passes under a pointer. Okay, under a pointer there is 300 big boxes is passes during a minute. In a 1 minute 300 big boxes is passes in a needles, in the deflections. So that means 300 big box is equal to 60 seconds. So in the one big square box, under a pointer, in a rolling paper it passes 300 big box in a minute. That means 300 big box is equal to 1 minute and 300 big boxes is equal to 60 seconds. That is 1 big box is equal to 0.2 seconds. So this big box is passing in a 1 big box, we will call duration as 0.2 seconds. So in a 1 big box it is again small boxes. That is 1, 2, 3, 4, 5. 5 small boxes is present in a 1 big box. Five small box, 5 small square box, and it is equal to 0.2 seconds. Then 1 small square box is equal to 0.04 seconds. This is the things has to remember. In a one small box, it is passes 0.04 seconds. The duration of a one small box is 0.04 seconds. How this 0.04 second means? Under a pointer, under a deflection, the speed of rolling paper is 300 boxes passes under the pointer. 300 boxes is passes under the pointer in a 1 minute. So 300 big boxes is equal to 1 minute, and this 300 big boxes we have to find out 1 big box square means 60 divided by 300 and it came 0.2 seconds. And again in the 1 big box it contains 5 small boxes. This 5 small boxes is equal to 0.2 seconds. So in a 1 small square box it will be 0.04 seconds. 0.04 seconds it takes place in the 1 small boxes. Now we will see the ECG patterns and durations of the ECG patterns. So we will take an example in a normal heart. In a normal heart, the heart rate is around 72 beats per minute. In a normal heart, is about 72 beats per minute. So in the normal heart, P wave will take time 2.5 small boxes. 2.5 small boxes will take P waves. P waves takes 2.5 small boxes. So 2.5 boxes is nothing but small box means in a small one box it is one small box is equal to 0.04 seconds. So in the 2.5 small boxes it will be same with 0.1 seconds. So in the P wave, the duration of P wave will take place 0.1 seconds. P waves will take 0.1 second. And after the P wave is nothing but atrial depolarizations. After the atrial depolarizations, AV node conductions will be passed. In the AV node conduction, it will goes in an isoelectric line and will form a ST segment. This ST segment also will take 2.5 small box. This ST segment also will take 2.5 box. ST segments also 2.5 small box. That is nothing but 0.1 seconds. After the AV node conductions, ventricles will be depolarized. Whole ventricles will be depolarized and QRS complex will be formed. This QRS complex will also take place 2.5 small box. So Q will give negative deflection, it will goes up and it will be form a QRS complex. In the QRS complex also will take 2.5 small box. And it is also same with 0.1 seconds. After completion of the QRS complex, that is nothing but ventricular depolarization. Before the ventricular repolarization will be start. Before the ventricular repolarization start and after before completion of the depolarization, it will form an isoelectric line. And it will be forms a this is known as PT segments. In the PT segments, after that atria will be repolarized and will form a T waves. Okay, and will form a T waves. T waves also will take so duration of the whole events of the ventricles will take around 10 small boxes. That is PT intervals. PT intervals will take 10 small box. So that is nothing but in 10 small boxes, one small boxes is equal to 0.04 second and 0.04 second into 10 is 0.4 seconds will take place. In the PR segments, also will take place. PR segments also will take place 2.5 small boxes. And here in the ST, whole parts of the ventricular events, that is QRS complex with the ST segments and the T waves, it will form a PT intervals. In these P intervals, it will take 10 small boxes. That means it will take 0.4 seconds. So mainly has to remember one small box is equal to 0.04 seconds. The duration of the normal wave pattern of the P wave is 0.1 seconds. So now we will revise the topics. So ECG is nothing but electrical activity of the heart. Electrical activity of the heart is graphically presented. That is known as ECG. So in the ECG mainly 12 leads are there. There are 3 are standard limb leads and 3 are augmented leads and 6 are chest lead or precordial leads. These are the 12 leads, and already we seen the placement of the ECG. After the placement of the ECG, we are seeing that how electrically events, what are the electrical activities in the heart, and these electrical activities of the heart is transformed into the vector. That vector we will known as cardiac vector, and this cardiac vector how produce the ECG pattern already we discussed. So in the electrical activity, first electrical activity will start from the SA node and will produce a atrial depolarization. In the atrial depolarization will produce a P wave. After the SA node depolarization will transform to the ventricle, but due to the it is in the fibrous tissue or fibrous annulus, it is not a good conductor. Because of that, it can able to pass the depolarization from atria to the ventricle. It can able to pass only in the AV nodes. AV nodes is also a slow conduction. Because of that, it cannot deflect or it cannot move the needle and will form a isoelectric line. This isoelectric line we will known as PR segment. And after forming the PR segment, ventricular will be depolarized. This ventricular depolarization we will known as QRS complex. So in the ventricular depolarization QRS complex, it will be processed under the 3 process. So first will form the Q wave, that is nothing but septal ventricular depolarizations. And after the septal ventricular depolarization, it will be depolarized to the major ventricular R and will produce an R wave. And after major ventricular depolarization, that basal area of the ventricle will be depolarization and will produce a S wave, and this whole we will known as ventricular depolarization. After the ventricular depolarization, before starting the repolarization of the ventricle, the heart will not pass any current and will form a isoelectric line. That line we will known as ST segment. And after the formation of the ST segments, ventricle will be repolarized and will produce a T wave. This is the electrical activities in the heart during a 1 cardiac cycle.